Welcome back to All This Math. This is Professor Parker, and shout out to the Haitians. You know what I'm saying? Sock passe to the Haitians. You know what I mean? You see my T-shirt. This is my Haitian Revolution T-shirt. See, I got Macondo, who was one of the Maroons out in the maroon spaces on the island in Saint Domingue. Then I got Boukman Duddy, Toussaint Louverture, and Jean-Jacques Dessalines. It was a lot of other people that was getting active, from 1791 to 1804, and after that, you know what I'm saying? They couldn't all fit on this T-shirt, but these are just some of the people. But I definitely recommend you go do your research on the Haitian Revolution. You can check out C.L.R. James' book, The Black Jacobins. You can check out The Irritated Genie by Jacob Carruthers. And there's some other books whose names I can't think of right now, but once you start going down that rabbit hole, if you start off with those two books, you'll probably keep doing research. You'll find some other texts that are very instrumental. You know what I'm saying? All right, now what are we about to get into? We're about to get into solving this equation right here that has a fraction on the left side of the equation and a constant on the right side of the equation. And it's a few ways to do this. I'm gonna do this problem a couple of different ways, and we're gonna see if we get the same answer, because that's one of the beauties of math is that we can do problems in different ways and end up with the same answer, right? So let's get started. Like what I'm gonna do is I'm going to how did I say I was gonna do this? Well, actually, as I look at this, I size it up because sometimes you should just take a moment and just like look at the problem and just size him up. You know what I'm saying? Just size it up and then just sit back and just decide what you're going to do. Like what's your plan of attack, right? What I'm going to do is I'm going to factor this numerator because this numerator has a GCF, a greatest common factor of X. Because this has an X in it and this has an X in it. So I'm going to pull that X out and then that's going to be my greatest common factor. And then I'm going to see what happens with this X minus one. All right, so check this out, right? So this is going to become X times the quantity of X minus 1. Why X minus 1? Because look, X is the greatest common factor of these two. So the way you figure out what's going to go inside the parentheses is you take the original terms and divide them by the GCF. So X squared divided by X is equal to X. Negative X divided by X is equal to negative 1. So this is equivalent to this. This is just a factored form of this. So I basically took this expression, which was quadratic, because the biggest exponent is a 2, and I broke it down into two linear terms or two linear expressions, a x and an x minus 1. All right. Now in the denominator, that's not factorable. That's already linear. So that's that, right? But look what I can do. I got an x minus 1 on top and I got an x minus 1 on the bottom. Whenever you see that, you could divide them and they turn into a 1 because that's like dividing something by itself because they're the same thing. So that's x times 1 over 1, which is just x, which is equal to 16. So that's our solution. At least I think that's our solution, right? You should always check your work whenever you solve an equation. Whenever you solve an equation, you should check your work. So I'm about to check my work up here real quick, right? Draw my check mark, colon, and everywhere I see an X at, I'm gonna replace it with 16, and I'm gonna see if this is a true statement. Because math is really about finding the truth, right? So I'm about to find the truth. Now, if this gives me if this 16 plugged in here, here, and here gives me a true statement, I multiply whatever, do all the math on the left side. If that equals 16, that means my answer is correct because it gave me the truth. So I got 16 squared minus 16 over 16 minus 1 is equal to 16. That's what I'm saying. But I'm trying to figure out, is that the truth or is that cat, right? So let's do the math. 16 squared is 256. It's not 32. This does not mean 16 times 2. This means 16 times 16. That's 256. 256 minus 16 is 240. That's 240. This whole numerator simplifies to 240. Then 16 minus 1 is 15. The denominator is 15. So you could grab a calculator and do 240 divided by 15, see what happens. Or you could do mental math if you know a little bit about the multiples of 15. Like if you know your 15 multiplication facts. If you do, you know that 15 times 15 is equal to 225. And then you ask yourself, well, how far away from 240 is 225? I know that 225 plus 15 equals 240. So that means if I do 15 times and then I add another 15, that's like saying 15 16 times. That takes me to 240. So that means that 15 times 16 equals 240. So that means that because I understand the relationship between multiplication and division, that means that 240 divided by 15 must be equal to 16. So because that's true, that means this is a good answer. All right. But what if I did this problem another way? Right? I'm going to do it another way and see if we get the same answer. All right. So check this out. Another way to do it, and this might not even be the only other way to do it, but another way to do it would be I could use what I call the Malcolm X method because I go into X formation and some textbooks call it the cross product property, but I don't want to call it that. I want to call it the Malcolm X method. Who's going to stop me? Right? So anyway, I do this numerator times this denominator. Now you saying this denominator, you might be looking at me like there ain't no denominator. Well, it's invisible, but I could write it. There you go. The way you change any whole number into a fraction is you just write a 1 underneath of it. That's all you got to do. Put a 1 underneath of it. So now numerator times denominator, that's going to give me x squared minus x because I'm just multiplying by 1. So ain't nothing changing, right? Then I write my equal sign. Then I do 16 times x minus 1. So that's 16 times the quantity of x minus 1, right? Now, the whole purpose of that was to eliminate fractions. All right, now my next goal is to create an equation in standard form, meaning all the terms are going to be on the left side of the equal sign, and I'm only going to have a 0 on the right side. All these terms are going to be on the left side of the equal sign, and I only got a 0 on the right. So check this out. I'm going to have x squared minus x minus 16x plus 1 equals 0. Now, I promise you, I'm explaining everything, right? I did a whole bunch just now, right? This x squared was already over here, right? It was right there. This minus x was already over here. Now, you should be wondering, where did this 16 minus 16x come from? I'm going to tell you. It came from the product of 16 and x. 16 times x is positive 16x. But what happens when you move a term from one side of the equal sign to the other? That's called transposing. The sign changes. The sign changes. So that becomes minus 16x. Where did this? Oh. I just noticed a mistake. Where did this plus 1 come from? This is a rookie mistake. This is a rookie mistake. This is a young boy mistake. All right, look. 16 times negative 1 is not negative 1, right? I must have been doing too much too fast, which happens to everybody. See, it happens to the best of us, right? So 16 times negative 1 is not negative 1. That's where that positive 1 came from. This positive 1 should not be here. This should be a positive 16 because 16 times negative 1 is actually negative 16. Negative 16 moved to the right side of the equal sign is going to become positive 16, right? So now that's how that's what's supposed to happen. All right, so then we got this and this put together. All right, we're going to combine like terms. So now we got x squared minus 17x plus 16 is equal to 0. All right, so now we got a quadratic trinomial. 1, 2, 3. Tricycle has 3 wheels. Trinomial has 3 terms, right? X squared minus 17x plus 16 is equal to 0. I can factor this. Into 2 linear binomials. All right, so I take the factors of x squared, which is just x and x. I put an x right here, I put an x right here. Then what I do, I like this method of factor because it's like playing a game, you know what I'm saying? So I take 2 factors of 16 that also add up to negative 17. 2 factors of 16 that add up to negative 17. So 2 factors of 16, I'm not going to use 4 and 4. I'm not going to use 8 and 2 because they're not going to work. I'm going to use 16 and 1. But I ain't going to use positive 16 and positive 1. Nah, I'm not doing that. I'm using negative 16 and negative 1. Why? Because they got to add up the negative 17. They got to add up the negative 17. So I'm going to put the negative 16 right here. It don't matter which parentheses I put it in. I just got to have one of each, right? I could have put the minus 16 over here and the minus 1 over here. It don't matter in case you had that question. All right. So now these are my 2 linear factors that are going to become my equations. X minus 16 equals 0. And then x minus 1 equals 0, right? Add 16 on the left, add 16 on the right. So I got x equals 16. Then over here, add 1 on the left, add 1 on the right. So I got x equals 1. Now notice something. When we did it the first way, we got positive 16. That was our only solution. But now I got 2 solutions. I got positive 16 and I got positive 1. So I know this works because we already checked this. But what happens when you plug in positive 1? If we plug in positive 1, right, we get an expression that does not exist because 1 minus 1, now 1 squared minus 1 is going to be 1 minus 1, which is 0. And then 1 minus 1 is going to be 0. So we get 0 over 0, which does not exist, all right? Because you can't have 0 in the denominator. We're not having 0 in the denominator. 0 divided by 0 does not equal 1. And even if it did, that doesn't equal 16, right? So this is what we call an extraneous solution. It's like something Dr. King said years ago. Dr. King said it. I think Fred Hampton echoed it after that. Sometimes you may get, if you're not moving appropriate with the appropriate political, in appropriate political context, right, and doing the proper analysis of situations around you in your community, in your society, you will end up with answers that don't answer, explanations that don't explain, and solutions that don't solve, right? So I remember Dr. King saying that, and like I said, I remember Fred Hampton saying that also. Fred Hampton, of course, from out in Chicago, Black Panther Party, young brother that was murdered by the Chicago police. When he was young, like 21 years old or something like that, right? So anyway, 1 is not a solution. 16 is a solution. So we did the problem in 2 different ways. We got 16 two times. All right. So just something I want y'all to think about. Make sure you're solving equations, and make sure, like I said, size the equation up. Decide how you're going to approach it. Decide how you're going to solve it, right? I decided to factor the numerator, right? I decided to factor the numerator, and then I got my answer. All right, and then I checked my work. I had to check my work too. All right. So definitely practice some problems like this. Make sure you know how to Make sure you know how to put these quadratics into standard form. Make sure you know how to factor quadratic trinomials using this method. Some people call it the reverse FOIL method. It's a lot of things you can call it. But yeah, go get some practice, and I will see y'all on the next video. Peace.